Today we're going to talk about how accelerators work. These problems are very similar to the problems that we've done. However, in this situation, we're going to see that net force no longer equals 0. It always equaled 0 in our past problems because those are problems were situations where the object was at rest. So, when it was at rest, it had 0 acceleration. Here, we are going to see we have accelerating objects where that net force is going to equal something. As we take a look at these, we are going to want to set up which way we will consider to be positive and which way we will consider to be negative. When we do that, we will want to think about which way we anticipate that the object will accelerate. So if I anticipate that the object is going to be accelerating to the right, I'm going to call that positive, and then to the left would be negative. If on the other hand I anticipated that it would be accelerating to the left, I could call left positive and right negative. And as long as these have opposite signs, we are going to be good to go. Let's take a look at an example. This is very comparable to problems we've already done. So let's say in this example, I have a hot air balloon with a mass of 413.27 kilograms. So I know that gravity is going to pull down on it. We're told that it has a buoyancy force, and the buoyancy force is equal to 50 newtons. It has a force of the motor pushing it to the right of 1520 newtons. Force of the motor, and then it has an air resistance force, and that is going to be pulling back with a force of 950 newtons. Now, just like we've been doing in all of our problems, we're going to set up stuff in the X and Y. Before we do that, we want to figure out which way is going to be positive and which way is going to be negative. In this case, since when I look at this, I see that my right force is greater than my left force, we can anticipate that overall it's going to accelerate to the right. So I'm going to say that right is positive, left is negative. And since we don't know anything about up and down, I'm going to keep our normal conventions that up is positive, down is negative. Now let's take a look in the Y direction and find out what's going to be happening down there. Okay? So if I set up a Y equation, I would say that in the Y direction, I have net force. That's going to equal force of buoyancy minus my force of gravity. I didn't just say that this is equal to 0 because in these situations, remember, we could have acceleration. So this will be replaced with mass times acceleration. That will equal force of buoyancy minus force of gravity, which is the same thing as mass times 9.8 meters per second squared. Let's fill in what we know and solve for A. We would plug in 413.27 kilograms times A equals 450 newtons minus 413.27 kilograms. Sorry, this should have been a 7 over here. I don't know why I wanted to make it a 5. Times 9.8 meters per second squared. Now, when I take a look at this and calculate, I'm going to find that I end up with 413.27 kilograms times A equals 50 newtons minus approximately 50 newtons, or that all of this equals 0. In this situation, we see that the acceleration in the Y direction, remember I'm only in the Y direction, is going to equal 0 meters per second squared. What this means is that our object is not floating. Tune in to the next video to see what's going to happen in the X direction. Try setting up the equation before you tune in, and then you'll be able to see if you got it right.